we're starting on time. So serverless community started in 2018 as a regular backend function service developers, but over the years it became more about agility and the mindset. And we observed the disconnect between the IT and business needs, and way too often we are like car mechanics flipping our cars instead of focusing on business, on driving business around. And we are trying to address that gap not only by having this metaphor of talking about the new serverless services, and you can see plenty of those talks on our YouTube channel, on the YouTube, serverlesstoronto.org. Also, because of the change in IT happens top down, we kept sharing ideas in the books for product managers. And then since COVID started, we started introducing more business-focused talks like this one. And then often, like when businesses start giving second opinions for free, because there is many of us here. A number of us are also consultants. We do consulting advice. And then when the going was tough during COVID, we were offering matchmaking services, connecting people looking for work in companies. Now that's no longer needed. So you can help us improve the quality of group by doing the survey. I will post the link in the chat soon. And then that will also enable you not to make us better, but also to win the Manning Prize. Manning has been a sponsor for quite some time. You can choose any of their products if you win at the raffle at the end. And then I hope this is not your first and last time coming to our meetups. We have some exciting topics lined up. There is lots of conversational AI coming to the call centers, and we're all excited about Alexas and Google Assistants. But when you put it in the call center, because of the quality of the line, because of different telco vendors, it's not easy to implement. And even Google, like yes, you have the best NLP technologies, but there is ES, there is EX, there is 5 partners you work with, so it's quite confusing to get the project right. And we are lucky there is a timely book on the topic, and Lee Bonstra, she's from Amsterdam, developer advocate, she's going to come next month to untangle people with some practical examples. So you're in for a treat. And for those of you who you're mentioning healthcare, I myself switching from pharmacy business to the healthcare business, and it's really hard to find the people who know both areas, like you mentioned, Rubina. And I was lucky to run into Dr. Kevin, and he's both a practicing doctor, emergency assistant professor at university, and IT developer. So it's going to be a cloud agnostic talk about smart or FHIR APIs that you can apply to either cloud of choice, because all cloud vendors are now, all major cloud vendors are now supporting FHIR standards to bring the data in, so machine learning and AI can work on top of that. I was finally able to get in touch with Philippe Hoffa, like this slide is here for months, but we haven't firmed up the date. It looks like he's going to be talking about his experience switching clouds, adopting Snowflake in December. So, and then we have November time slot available if you want to share anything. It doesn't have to be like book authors like Lak and Lee, anything that's non kind of promotional and good for group, for humanity, you're welcome. Reach out to me. And Lak, I really like your old course from Pluralsight about machine learning for business executives. That's when I decided to reach out to you, because it's not often about technology, but about a direction businesses are taking. And Coursera had the same course, but Google has updated the old version. The one I like is still available here. So if you guys sign up for 10 days free trial, you'll be able to quickly go through that. I put Lego pieces, but your book sounds so many diverse topics. Like look at this. Like I'm still at the first one, and so you see things many people don't. So we are in for a treat to hear your perspective on the AI and the future of DataCloud. So thank you for stopping by. Please take it away.
Absolutely. Thank you, Daniel. And it's funny that you would say that the old course is the one that you like. Of course, like
this too. This too. Like this is so ahead of the
first
time.
book is the one that you love the best.
So thank you.
Neat. And again, I couldn't agree more with Lee Bonstra, who's going to be the person speaking next week. She's awesome. Now, if you want to learn about how to build conversational agents, she is one of the experts at doing that. So definitely a great speaker, really knowledgeable in that area. Same with Philippe Hoffa, even though he's no longer on BigQuery and Google, like a great friend of mine, a very good speaker. So you have a very good lineup of folks coming on. So today, what I'm going to talk about, it's like what Daniel said. What am I seeing, right? So when we look at a lot of companies that are trying to adopt analytics and AI, okay, you basically run into a few challenges. So I'm going to be talking about enterprise challenges and what are why do they happen, and what are some ways that we as a cloud provider, Google Cloud, how we're helping address those challenges. Okay, so this is not an intro to ML or an intro to data analytics. It's much more around a survey, if you will. But again, feel free to stop me at any time, right? And if you want to discuss something, just drop things on the chat, and I'm happy to basically delve a little bit deeper into some of these things. Okay? So first of all, right, what is the reason for which people use analytics and AI? It's always good to like what Daniel said, you can be hung up so much in how the engine works that you forget what the car is used for. Okay, so why do you basically use analytics and AI? One big reason is that you want to build great products and you want to bring them to market faster. Okay, and when you think about that, you want to basically, you often build products. You want to identify the highest value customers, and you will have a number of products as a company, and you want to basically figure out which product you want to provide to which company. I mean, this sounds like a very business problem, but this is the exact same thing if you're saying in public health, as Rubinia was talking about. You have a multiple different types of advice and conversations that you can have with the people that you want to provide medical advice to. Which one do you pick? It's a product, and you're basically trying to find the right product at the right time. And of course, as with everything else, you really care about the end user experience. And when you think about the end user experience now, all of our customers have been spoiled for choice. They're so used to getting a very personalized experience that is what they expect. This idea of basically building something that you sell, stock it high and just sell it cheap, doesn't work anymore, right? You need to basically go ahead and build things that are unique for that customer, and you need to basically figure out how to build those better products. And very importantly, you need to learn how to adapt in real time as the market changes. So that speed is very important. So when you look at a business and you ask a CEO or a CTO, why are you investing in data and AI? They'll basically tell you one of these three things, or they'll tell you all three of these things. They'll talk about how to identify the most profitable customers, how to build better products, and how to be more agile, how to adapt in real time. Okay? So those are all what you might think of as the front end, the things that the customers experience. But there's another reason to use analytics and AI, which is more on the back end. You may want to basically figure out what is wrong with your supply chain. Why is your shipping taking so long? Why are your developers taking so long to build a new product? Why is your ML models why are they so expensive to train and run? So these are more on the back end, on the more computational infrastructure, or the infrastructure of provisioning a product or taking a product to market. So you have improve the back end efficiency as well. So there's one set of use cases for analytics and AI that's all about increasing the market, and the other set of use cases that's all about decreasing the cost. Okay? So those are the two general themes when it comes to why do you use analytics and AI. So both of those things used to be done through data analytics. So when we look at how do you build better products, you would basically build analytics and you would solve them. When you think about how to basically achieve better cost efficiencies, you would basically have data analysts, business analysts looking at the different costs of the business and figuring out how to get them down. These days, though, AI is the exciting thing. So why is all of this hype around AI and ML? So when you think about it, AI is essentially where you're taking a computer and you're basically getting the computer to think and act like a human. At one level, every computer program that we write is an AI system, because you're teaching the computer to make the kind of decisions that a human does. But the problem with thinking about it that way is that programming is a very hard thing. It's really hard to capture human judgment. And so you end up taking approximations, you end up interviewing experts, trying to figure out what they do. So that whole idea of capturing logic was very, very, very hard. So this branch of AI called machine learning has become extremely popular, because rather than try to get the computer to understand human logic, instead you try to get it to understand human decisions. You say, here's a bunch of data with the correct answers. Now you machine go figure out how to learn from that data. And it's, in many cases, it's easy to get the correct answer than to basically get the human logic. It's very hard for you to determine, why did this individual react when the warning, the public health warning, was phrased in this way rather than this other way. It's really hard to express that judgment. But if you basically did like an A/B test, and you basically had 50 examples of phrasing 1, 50 examples of phrasing 2, and then you looked at how people reacted to those 50 each, you now have a natural machine learning data set that you can go build models off of. It's a lot easier to collect data than to get people to explain their judgment. So that's why ML is very popular, because data is easier. But then deep learning came along, starting in Toronto, right? And that University of Toronto pioneered this whole idea of deep learning. And the idea that machine learning, which had been done for a very long time using models like SVMs and neural networks, by adding depth, you could actually get ML models that could be trained just on data, on unstructured data, on images, on video, on natural language text. That is extremely exciting, because we have no other way to train those models today. So this idea of collect enough data with the correct examples, and you can basically solve any of these problems, is what is exciting to a business, right? This idea that you can figure out which customers are valuable by figuring out what customers buy. You can figure out which end user experience is better by simply doing an A/B test on your website and choosing the right kind of interventions to take. You can figure out how to adapt in real time by basically building time series models that forecast changes. So all of these are much easier when you frame it in terms of data than in terms of logic, because logic is really hard. Data is much easier. Okay? So given that, though, if you want to build, so this is now, we're not talking about what are the challenges that you face if you want to basically solve business problems with analytics and AI. So challenge number one is that if you want to build a high quality AI model, today you need a lot of data. How much data? Okay, this is one of my favorite graphs. This is basically showing, this is a translation model, but it's very similar regardless of the type of model you're talking about. On the x-axis is the number of tokens that you need. On the y-axis is the error rate. So the error rate drops as the data size increases. Yeah, okay, you understand that, but look carefully at the x-axis here. It is 2 part 20, 2 part 21, 2 part 22. What's happening at every tick mark? The data size is doubling. In other words, for a linear decrease in error, you need to double the size of your data set, 4 times the size of your data set, 8 times the size of your data set, etc. That is the challenge. If you want to build high quality AI models, your data size is literally growing exponentially. That's the challenge. So we say, oh, let's go build a better model, a deeper model, a model with more parameters. Well, that's what is shown by the orange line here. Okay? If you don't have enough data, building a better model doesn't give you much of a payoff. It's only when you have so much data that your model is plateauing that building a better model gives you better performance. Okay, so if you don't have enough data, stick with simple models. Right? So that's the challenge. Now, why does it work that as you increase the amount of data, you can use a more complex model? It works because the more complex model has more parameters, it's more deeper, but also it's more computationally expensive. So put these two things together. If you want a high quality model, you need 32 times, 64 times more data, and you need a model that is much more expensive. Now you see the difference between AlexNet, which is what I talked to you about like in Toronto in 2014, right? To neural architecture search, which underlies Google Cloud's AutoML, or AlphaGo Zero, which is like the protein folding stuff. And the difference in computation is around 300 to 500,000 times. So what you could do on one GPU in 2013, right? If you want to solve those kind of problems today on the much larger data sets, much more accurately, you need 500,000 of those GPUs. That's the challenge. Right? So challenge number one, yes, you can do high quality AI, but you need lots of data. And the corollary to that is even if you have lots of data, you're going to need tremendous amounts of compute. So how do you address those challenges? Well, one way that you address the challenges is through this technique called transfer learning. The idea behind transfer learning is that you take your very complex model, this orange model in this graph, and you train this orange model on a really large data set. That's called pre-training. But that really large data set is not your data set. It doesn't solve your problem. So what do? What you do is that you take that pre-trained model and you freeze all of the weights and you chop off the head of that model, put your own head onto it, and you train only your head on your data. So how does this help? A high quality image model these days needs about 10 million images. So you pre-train on 10 million images. And then you freeze that model and you bring your own data set, and you can get away with 100 images. That's the advantage of transfer learning. But if you need transfer learning, and this is where cloud computing comes in, if you want to have good transfer learning, what do you need? You need a high quality pre-trained model. Okay? That's where we come in as a cloud provider. Right? So now when you want to say, I want to do my object tracking on videos, you need a tremendously large data set that has been pre-trained for object tracking that you can now adapt on your much smaller data set. If you want to do shot classification, you want to recognize actions, you want to have a pre-trained model that has been pre-trained on a very large data set on the type of actions that you can fine-tune. So you can fine-tune a general purpose model. You're not going to get as good performance as if you can fine-tune or transfer learn on a model that's been pre-trained on a data set that's very close to yours, on a problem that's very close to yours. And so the question is, like, what's the difference between a cloud that's focused on AI and a cloud that's not? Part of the difference is the quality of the pre-trained models that you get. So that is for unstructured data. So the solution for unstructured data is use transfer learning, but use high quality pre-trained models. The second thing is, suppose you have structured data. Okay, structured data meaning tabular data. Pre-training doesn't work on tabular data because there is no data like yours. Yours is the only data set out there because your data set is unique. It's to your industry, it's to your company. That's what you have. So how do you get something better? How do you get a larger data set when it comes to structured data? But the way you get a larger data set on structured data is by increasing, there's two ways to get a larger data set. You can increase the number of rows, or you can increase the number of columns. Increasing the number of rows is very difficult. If you're a business and you have a set of transactions, that's the transactions you have. It's going to be really difficult for you to go get more customers, right? You are stuck with the number of customers you have, the number of transactions you have. Your number of rows is fixed. But the number of columns, there is opportunity. You can basically go join against other data sets, other information that you have, right? And that's the way that you improve a structured data model. You build in more features. And how do you build in more features? Well, you break down data silos within your organization, right? If you're training something, don't train it on just the data within your department. Go get data from the other departments that basically have relevance to your problem. And do this, of course, by keeping the data live, because you want to be agile. So you want to minimize your data movement. And that's where the data platform like BigQuery comes in, because it allows you to basically break down data silos. There's only one BigQuery. It is serverless. There are no clusters. There's nothing to spin up. Everybody has their data set on BigQuery. And you can, and as long as they give you permission, you can join their data set against yours. So that's a huge benefit to using a cloud platform without data silos. So challenge number one, you need lots of data. Gave you two solutions. One is high quality pre-trained models that you transfer, learn off. And secondly, break down data silos, taking advantage of a serverless data platform. Challenge number two, AI expertise is in very high demand, which is great for you and I on this call, right? This is good. But it also limits the amount of AI adoption that happens in the enterprise. When you look at who can do net new machine learning models today, there are about 10,000 deep learning researchers who can create net new deep learning models. Maybe 2 million machine learning experts, like the folks on this call, who can take deep learning models and train them and make them work in new domains. But we have 23 million developers and 100 million business users. Can we not get them doing the initial bit of machine learning? Right? That's the basic idea. The idea is there's so much opportunity for a business to improve the way that they use data that it would be awesome if we could get business users to build simple models. And then once we have the value proven, it then comes to the ML experts to build better models. Something is better than nothing, in other words. So how do you get that democratization of AI? How do you get lots and lots of simple models out there in the enterprise so that, like the ML experts, we move up in the value chain? If we are out there building simple models, we're only getting simple benefits, right? But if we are basically building models that have extremely high value, because here we have 100 million people experimenting on our behalf, and we are picking the most promising things that have been proven to be promising, and we're putting those into production, we basically get much better payoff in any enterprise that we are. So how do we get to that point? Well, how do we get business users using AI? Well, what tool do business users use? They use Tableau, they use Looker, they use dashboard tools, they write SQL queries. Hey, why don't we write machine learning models in SQL? Well, that's what I'm showing you here. So you have your data set, which you select your data, And then you say, I want to train a logistic regression model, or I want to train an XGBoost model, or I want to train an AutoML model with one of these columns as the thing I want to train for. That's my label. And the rest of the columns are my features. Think about it, right? Structured data. This is mostly what we do. And this is amazing because we've taken out all of the hard work in extracting the data, cleaning it up. Everyone knows how to clean up data in SQL, right? You know how to basically do is not null in SQL. You know how to basically do a regular expression. You know, you can do all of those things, and our users can do those things. So they can go train their model. And then once they have that model, they can basically go try predicting on that model with, here ML.predict. So you've not moved the data at all. And you can do even things like BQML, like BigQuery ML, keeps getting better. We can now do hyperparameter tuning. You can now do explainability. You can do AutoML. You can do deep neural networks. You can do XGBoost. So this thing is like getting better and better and better. So what this means is that you have the bar for what a simple model is getting better and better and better. And all that someone needs to know is SQL. So that initial model, you can democratize it within your entire organization. So now, given that you have that, what does your AI strategy now become? How do you democratize it? So the suggestion is you basically take your AI use cases and you break them into 3 buckets. Bucket number 1, right, is the one that you keep for yourself. I'm going to build end-to-end AI from scratch because this is very high value. It is very differentiating for my company. I'm going to spend a lot of effort, right? We'll give you easy to use tools, but you're going to basically take all of your knowledge of AI and ML and build really high quality end-to-end models. That's 1/3 of your portfolio. The other third of your portfolio, you're going to do what is called customization. You're going to do transfer learning. You're going to do BQML. You're going to do those things where you do a little bit of adaptation, which a lot of business users can do. AutoML, BQML, transfer learning, medium effort, a little bit of customization gives you a really high quality baseline. Something's better than nothing. You're out there. And then always keep on the market, look out for out-of-the-box tools, like what Lee is going to talk about next week. Like if you're going to build a chatbot, don't build a chatbot from scratch, go use Dialogflow, right? So show you those out-of-the-box AI kinds of tools, low effort, you can do those, you can build very high volume, they can be done with developers rather than ML engineers. So developers for AI out of the box, business users for custom AI, and ML engineers for end-to-end AI. And the idea is that you have a lot more of people working on the first 2 buckets than on the 3rd bucket, and you can get equal reward from all of these 3. You want to be able to do all of them. But once you have a portfolio of AI models, you're going to run into one challenge. Some things are going to be built in BQML, some things are going to be built in SQL, some things are going to be transfer learning with AutoML, some things are going to be end-to-end in PyTorch, and in a real use case, you're going to have to mix all of them. You need a unified platform for all of your AI models. And of course, we have an answer for that. And that's one of the things that we do very well in Google Cloud, is whether you're using a pre-trained API, whether you're customizing that API, or you're building it end-to-end, it is the same platform. It is the same platform, whether you're buying, whether you're customizing, or you're building from scratch. So that's extremely important because you can put all these things together. Okay? So challenge number 3, if you want to get value out of ML, you need a modern data platform. Where are you going to get your modern data platform? How are you going to build it? What's involved in a modern data platform? Okay, so let's take an example. So this is the Home Depot website. So Home Depot is this do-it-yourself home equipment company. So I go to Home Depot and type in water heater, and I basically get this page, and it tells me that there are 2 water heaters at stock at the Lander store. Where does this information come from? It comes from an operational database, because as soon as somebody goes and buys that water heater at Lander, this has to show 1. Home Depot shouldn't make me drive all the way out to the Lander store to pick up a water heater that it doesn't have in stock, right? So you need an operational database to put this part of the website in to say you can pick up the store here, and an ERP system, operational database, an ERP system for inventory management, SAP, etc. So you need that, right? The next thing that you need, look here, it says here's a water heater. I just searched a water heater. It says there are 266 water heaters we have. This one is a bestseller. It's rated 4 stars. Here are the reviews. Where does that come from? That comes from BigQuery. That comes from your analytics data platform. So immediately this page involves some data, right, from your database, but also like delivery is free to your home. How does it know that? Because there's a GIS computation that's happening from my home address to the Lander store. It's less than 75 miles, sorry, miles, not kilometers. And it basically says, okay, it's within my delivery distance, so your delivery is free. All that has to happen. It's a personalized delivery estimate that is happening here. Next thing, scroll down. It says, oh, you're going to buy a water heater. Don't forget, you need all these things to fit the water heater with your system at home. Where does that recommendation come in? Machine learning. It's a recommender system that's been built of previous transactions, of the manufacturer's catalog information. The point is, even a simple user journey involves building a data cloud that connects databases and analytics data platform and machine learning, all tied together in an application that surfaces it, an application that both reads and writes. It basically shows you all the predictions, but when somebody buys a store, somebody leaves a review, these need to go back and update it as well. So you need a full data lifecycle. So don't buy one thing in this diagram. Buy a unified platform that allows you to tie everything together. Right? That allows you to tie everything. That's super important, because you want to spend your time building all this functionality, not tying together and gluing together everything separately. So the point being, when you pick a data cloud, you basically want to unify data across this entire organization. You want to break down your data silos. You want to increase that agility. You want to reflect how many items you have in stock. You want to innovate. I mean, can you imagine the sales uplift that happens when Home Depot is able to show the fittings associated with a water heater, the number of returns that get reduced, right? The amount of top line revenue that gets saved because people aren't buying 3 different fittings and returning the 2 they didn't use. Right? There's a lot of benefits to building a really data-driven system that allows you to build really accurate models. That value from data is incredible. And that transformation that you can drive if you tie all the 3 systems together is the thing that that enterprises want. Right? When they talk about, hey, I really want to use AI, this is what they're talking about. They're not talking about, I want to use efficient net. They could care less if you're using efficient net. Right? What they care about is that you know how to tie these things together and land a use case for them, a customer journey for them. Okay? So, and you have to do this in a real-time personalized way. That is super important, right? It's not enough to build an ML model. It needs to be done in streaming. Your predictions have to come out in a streaming prediction, and it has to be done in a personalized manner. You have to take into account things like, where does the user live when you compute the delivery fee? You don't want to put on your website, delivery is free if you live within 75 miles, and tell user, it's up to you, go figure out if you're within 75 miles or not, right? That's important. You need to basically provide a personalized experience that is in context, that works. So, which is why, right, we keep saying, right, you can't basically build systems that require you to run infrastructure. You need to forget about infrastructure, and you need to think about just code and allow the infrastructure management to be done by your hyperscaler, whoever the hyperscaler is. And obviously, I would love it if you chose us as a hyperscaler, because we have an integrated platform that we've been very, I think one of the unique things is that we've been very thoughtful about making sure that everything in our platform is integrated. So we don't have 50 databases. We have 3 of them. We have one relational database, we have one global database, and we have one NoSQL database. And we say we're done, right? Here's 3. We'll put all our eggs in these 3 baskets, and we make sure they work. We have one analytics platform, BigQuery, that works on really small data sets to really large data sets. It's just one thing instead of a dozen things. So that unification is very important to us, because as Google, we've been in this space for such long enough that we realize that the challenge always is a proliferation of technologies, and you don't want that. You want to have this unified platform in order to drive that speed of innovation, right? You really focus on speed. Okay. So challenge number 4, equally important. You've built your ML models, you've tied together your operational database, your data platform, your ML. You have your ML. What do you now need? You need to activate it. Activating it, what does activating it means? It means that the ML model has to show up in the decision user interface. It needs to show up in the tool that the end user is using, right? So imagine that you're basically building an ML model to help a repair person estimate the cost of a repair. Where should that UI live? It needs to live in the mobile phone of the technician visiting the thing that needs the repair cost estimate. So when we talk about AI models and surfacing them, you saw when I showed you in the Home Depot case, where was all the AI exposed? In the Home Depot website, where the customer could place an order, right? That's what we mean by a decision UI. Where the decision is made is where the AI model needs to basically land so that it basically gets activated. Okay? So how do you do that? Well, you're basically talking about taking your analytics, taking your predictions, and exposing them in mobile applications or exposing them in websites. And one of the easy ways to do that is to use tools like Looker that allow you to embed the analytics. Okay? So you're really looking for a way to basically take the results of AI models, but not just the end result. I mean, in this case, in the Home Depot case, for customers, you don't need to do too much explainability. It's enough for me if you tell me that delivery is free. You don't have to explain why. But if you're talking to somebody who's an expert, if you're talking to a mechanic and you're telling them that the cost of the repair is going to be X, they're going to want to ask you, why are you saying the cost is going to be X? Show me a breakdown, right? So the way you're going to expose the result of the ML model is going to be in the form of graphs and charts and so on. So the exposing, the activation has to be more complex. It has to carry through with it an explanation of why you're recommending what you're recommending. It's not enough to just put a black box answer. The second challenge is when you activate the ML, right? you're often not activating. The website is easy. You're activating it on the cloud. So that's cool. But activating it on a mobile device, that's much harder. Mobile devices have lower power. They may not be always connected. So you now need to run the ML model on the mobile device. You're now talking about edge deployments. So what you need now is a way to train a model on the cloud and strip it down and compress it and make it low power enough that you can run it on the edge. So what you need is something like TensorFlow Lite, right? A way to basically train a high quality model, but have that high quality model be expressible in a lower size factor, lower power factor, so that you can basically put it on the edge. So this is where you knowing that there are models like EfficientNet come in. Models like MobileNet come in, right? So now you say, okay, I need to train a model that is very accurate when I train it on the cloud, but when I compress it, it won't lose accuracy. And what is the type of model I'm going to pick for that particular use case? And now you're basically looking at the more narrower segments and basically taking your knowledge of the domain and those choices to make those things. And of course, you also, sometimes you don't do it on a mobile phone, you might do it on your own embedded devices. And yes, we have an answer for that too. That's called Coral. It's basically an embedded chip that you can basically add to your own hardware in order to carry out your agenda. So challenge is, okay, I'm not counting right. Okay, challenge number 5, operationalizing ML is hard. Okay, so you now have a way to activate it. The next challenge that you have is that you have to operationalize it. What do I mean by operationalize ML? But what you've done is that you've created an ML model. What you haven't thought about is how does this model have to change over time? That's where engineering comes in. Okay? Developing the first time is science. Keeping it running forever after is engineering. Okay? So you need to basically figure out what happens if the data starts to change. What happens if customers start to catch on, right? Customers start to do certain things, right? What happens if customers realize that if they do these 3 sequence of things, we will always give them a coupon. So they always go through this thing of adding something to the cart and removing it, knowing that when you remove it from the cart, you're going to give them a coupon. How do you basically start to understand that these people are basically catching on, and you have to basically figure out how to deal with those kinds of things? That's what operationalizing ML means. It means basically monitoring the model, continuously evaluating it, figuring out when the data sets change, retraining the model. All of those things need to be all automated. So what you need is you need to go back to when you developed the model in the first place and use a journey that gives you flexibility and consistency. The same kind of things that I talked to you about, the analytics data platform and it needing to be unified at a more granular scale, it's true of ML as well. You want to make sure that whether you're training an AutoML model or custom code, you can basically evaluate both models the same way. And if a model starts to basically drift in performance, you have automated ways of starting a retraining process and retrain immediately in an automated way. So the way that you do this is with what are called pipelines. Okay, Vertex AI pipelines, which allow you to capture every step of your ML flow into a single API call. And then once you have that in an API call, you can say, whenever new data comes in, I have 1,000 new rows, relaunch the pipeline train. And you can basically do that in an automated way. So that's what you need. So all of the things that we used to do in DevOps and application engineering, you have to do in ML as well. You need to basically take each of your steps. You have to containerize them. You have to have them in a container registry. You have to put together a pipeline. You have to make this pipeline a single call with a REST API. And that call needs to be launchable from your continuous evaluation step, so that every time you get new data, you're always reevaluating. And you're reevaluating whenever you get new predictions. You're saving a sample of those predictions. There's a whole bunch of practices that you need. And as before, you don't want to be responsible for doing those practices. You want your cloud platform to do those things for you. Okay? And that's where our Vertex AI comes in. So whether it is data labeling or model training or all of these things, we basically provide managed versions of model monitoring and explainability and feature stores and metadata management and pipeline creation. So all of these things are fully managed, which means you can just focus on, here's my code, manage it for me. Okay. So now the purpose of that thing, because operationalizing is hard, you need pipelines, and you need that higher value thing than simply an environment that lets you run open source code in a faster way, right? So final challenge, again, this is something that is absolutely true. It's always amazing to me how far along we've come in the last 5 to 6 years, right, in terms of machine learning. And the state of the art keeps changing, right? So for example, neural architecture search is a way that you now build much better models. How do you get access to neural architecture search? Or, right, if you're basically, so that's another thing that as Google Cloud, we pride ourselves on doing, is we're very tied in with Google Research. And as new models, new techniques get invented, we look at ways to productionize those and put them behind very simple APIs to basically make them usable by like everyone else. So when you look at, for example, Google's Document AI, it captures the best of things that we've learned on NLP, so that not everyone needs to be an NLP expert. You can use Document AI to parse your forms, and you will get the benefit of all of the neat work that's been going on, and you continue to stay on the leading edge. So to summarize then, right, what are some of the challenges and how can Google Cloud help, right? We can help you leverage AI more effectively by, number one, helping you train on less data by customizing our high quality pre-trained models, help you develop AI fast by training models in SQL without moving data around, help you do large-scale ML by taking advantage of AI accelerators like TPUs and GPUs, notebooks to speed up ML development. And that integration across databases, the analytics data platform, and machine learning to build this unified AI and data pipelines is super important, because that's the way that you get your speed of execution. And now we can give you ways to activate your analytics and ML through something like Looker, operationalize machine learning with Vertex AI pipelines, deploy ML on the edge with TensorFlow Lite and Coral. But I think at the end of the day, right, Google's promise on data and AI is, look, this field is changing so fast. You want to be with the leader. That's who we are. Come work with us. Thank you.
Wow. Thank you, Lak. Amazing. You're not just a brilliant storyteller, guys. This is a reality, not fairy tale, what you heard.
Thanks, Daniel.
Let's start with the questions. We have plenty of time, so we have half an hour to 45 minutes for questions. Any topics dear to your heart, and what is beautiful here, this is applicable across cloud environments. It's so generic, like everybody should watch this recording regardless where they live. So thank you.
Yes, Zoran.
Thank you, Lak, so much. Please, is there an AI-based tool that can scan input and output to the transformation step on the on-prem legacy system and generate equivalent BigQuery step? For example, if we have a sort on the original step, it's easy just by looking at input and output to figure it out. But for any other transformation, it should be possible to do the same with input. And such tool, if there is any ambiguity, could generate the records that when fed to the input, can remove ambiguity.
Right. I mean, that's a very good question. As far as I know, there is no tool that generates output from input, right? So there are tools that will help you create a SQL query if you explain the logic in natural language terms. So you say, here's the logic I want. I mean, Google Sheets does that. So you can go into Google Sheets and you can say, I want you to show me the top 5 producing regions. And it looks at the column names and basically creates a SQL query. And it basically shows you BigQuery Q&A does that. It generates a SQL query given a natural language. So you can have somebody speak what they want and you can have the SQL query generated. So that exists. The other thing that exists is if you have legacy SQL, you have SQL converter tools that will convert the old SQL into BigQuery SQL. So, and these tools support dozens of different dialects, whether it's Teradata or Oracle, Exadata, etc. So if you have old SQL, you can convert it into BigQuery standard SQL. So that also exists. But I'm not aware of a tool that does this. Here's my input data. This is what I want. Because if you want that output, you have to be able to have some kind of a logic, some way of creating it. It's a large enough data set that you've done it, right? So you must have some way you did it. So let's basically look at how to translate it as how people have been approaching it.
Thank you.
Thanks, Aran. So I guess I'm seeing a few things in the chat as well. Okay, that's Pluralsight, ERP. Oh, yeah, thanks, Rodrigo.
Any questions further? Any topics really, like Lak has so many books on different topics. It doesn't have to be high-level strategic.
Yes, Ravina. You're muted again.
Yeah, hi. In my experience, I have seen that mostly it has been the CEOs and the VPs who care about the insights from the data, but sometimes that I see that the operational levels, they are not as passionate or not as concerned. And sometimes when they are entering the data, they're like, oh, whatever, it doesn't apply.
Data entry errors and so on.
999. And also I have seen, for me, for example, I started being interested in data since my undergrad, because with SQL, I knew. And then when I went to do my internship, it was the owner of the company who was like, I want information, I want process, but the normal workers, the regular workers, they were not as concerned. But I think my point and what I want to say is, I think there's gonna be a mind revolution too, in which now at each level, everybody is going to care for input quality data. And then that is going to be, it's not only the VP and the CEO who wants insight, even the person in the lowest level is going to need data now. And
you said it right, Lavinia. It's basically what we call a data culture. That data culture needs to be built throughout the organization, because otherwise, garbage in, garbage out, always, right? And it's really hard to correct data if people are not careful about what they are storing, right? So the data culture is extremely important.
And it is a worldwide phenomenon.
Absolutely, it is. It's everywhere where you need to basically inculcate that data culture. And what we have found is that you tend to basically get that benefit only if the people producing the data get a benefit from the data as well, right? So you want to make sure that when you produce the data, you get insights from it, right? And as soon as you do that, there's a lot of cleanup that happens naturally, because people want to get good behavior, right? Good things out of their data.
Thank you. And I have one last question.
Mm-hmm.
What is going to happen with those star schemas for data warehouses? Are they going to disappear? I don't know.
Yeah, I mean, like technology changes all, every couple decades technology changes. So who knows? Maybe 15 years from now, star schema will make its way back. But
look, I think
like every generation of technology, there is a schema structure that works better with it, and that's all that you're seeing. It's not that a star schema is unworkable in a data warehouse. It's just not worth the effort of creating a star schema.
Makes sense. It's a lot of work.
Lak, can we tie it into second question related? Like I read somewhere, was it you or Fivetran, that for migrating into cloud data warehouse, you just import schema as is and then optimize later. Would it be a recommendation?
I'm sorry, to just
migrate. When you're migrating, so you had enterprise data warehouse, it was star schema all product. Now you're moving it to BigQuery or Snowflake. Is it a recommendation just move it as is first and then optimize it as it goes?
Yes, absolutely. Yeah, the recommendation these days is to just all of the data warehouses can deal with star schema, right? There's really no requirement that you basically denormalize absolutely everything. You don't have to. So move it as is, and then after a while, if you need the performance benefits, you can do that. But again, the optimizers on the back end of these things are good enough now that most of these kinds of, no, I'm going to break my star schema and denormalize it, may not matter anymore. They're going to do a broadcast join anyway, and it's going to be pretty efficient anyway, and it doesn't really matter.
Next question. Don't be shy.
Michael Cho, do you see BigQuery ML getting to a similar sophistication level as Python? It's actually targeted at this whole democratization audience. So we are purposefully not adding all the bells and whistles that you would add in, say, my Python API to BigQuery ML. Having said that, you've always heard of the Pareto principle, right? You get 80% of the benefit from 20% of the work, first 20% of the work. And that's the deal with BQML, right? It's enough benefit that you will get from what is there that it's going to take a long time for you to actually start beating AutoML and BQML, right? So these starting points are really good and they keep getting better. And so you want to basically keep that in mind. And that's why, when I was talking about my 3 buckets, I said really devote your end-to-end ML development to your really high-value differentiated data sets, because most of your use cases are not going to benefit from an extra 1% accuracy, right? You're going to be okay with the accuracy that a BQML or an AutoML is going to give you. It's much better to have something out there than spend 8 months building something that is 1% better. So you want to save your effort for the really high value stuff. And you want to basically treat this as, I'm going to do fast experimentation and get something in production very fast. And then once you have it in production, you will discover that 1 or 2 of those 50 models that you've built are super impactful. And those are the ones that you're going to now take and say, how do I reformulate this problem? How do I make it better? Okay? And then you basically can get dramatic improvements, not by changing the ML model, but by reformulating it. Right? And an example I have of that is, we had somebody who was basically building a packing system, right? They were basically trying to say, what things do I put on this shipping container? And the way that they were doing it earlier was very heuristical. And they built an ML model to basically anticipate the weight of new boxes that are going to come in later. So they could decide when to hold off and basically pack the container better based on the anticipated items that were going to come in. And that ended up saving them several tens of millions of dollars. It was a simple model that just a demand forecast model, right? And then they basically ran their packing engine and they packed it. And once they realized that that was really useful, they went back and said, okay, now that we know this is useful, let's build a real packing system. Now that's no longer a simple ML problem now, right? It's a much more complex problem that's around packing. It requires dedicated experience and expertise. And now that tens of millions of dollars saving became hundreds of millions of dollars because they were able to focus their really high value data scientists on this much harder problem to solve, right? Rather than them training slightly better regression models, which is what they would have been doing otherwise. Right? So let the slightly better regression models be done through BQML and let go. Just keep creating a whole bunch of those, and then take like your 5 data scientists and say, build me a better packing system, and that's where you get your benefit.
Well, okay, thank you.
Who's next? I like your point about building amounts of data versus algorithms. Too many companies are excited to build their own algorithms, and then there is no data. So I think for people listening to this recording, if you're taking one point to help companies, just tell them do not do that. So
Yes,
maybe you can
absolutely.
iterate.
Yeah, if there's one point you take away from my talk, it is that, and this is the same thing what Andrew Ng says, right? The people with more data beat the people with better algorithms, day in and day out, right? More data, better data beats better algorithms every day. So what you want to focus on is getting better data, getting more data, break down data silos, collect as much data as you can. Okay, the better models are not the thing that gives you better benefit.
That's cool. And recently you had a chat with some folks from ELT companies, and you were the only one talking about streaming. Everybody's about micro-batching, data flow, real-time. Maybe you can elaborate. You have a number of talks on the topic.
Yeah. So definitely. Micro-batching is a cheap hack to get around the fact that what you want to do is real-time decisions. Okay. And so, okay, why do I say it's a cheap hack? Because there are things that micro-batching will not let you do that are very, very, very important. Okay. Almost every business decision is made not on what's happening today, right now, but on a cumulative thing, right? So you basically want to figure out what's happened in the last hour, what's happened in the last 2 hours, what's happened in the last 3 hours, what's happened in the last 4 hours, etc. So what you need is something stateful that's standing there, that's collecting that information, computing those aggregates, and keeping on making decisions on those moving averages. Because if you're not making decisions on those moving averages, you're making decisions based on noise, right? And that's the challenge. It's not about, oh, I was doing my decisions once a day, and I want to make my decisions once an hour or once a minute. It's not about doing a decision once a minute. It's about making sure that your decision that was made once a minute still has access to a rolling 24 hours worth of data. That's what stream analytics is. You want to make this distinction between stream processing, which you can do with microbatch, and stream analytics, which is where the value comes in, which is something that you can only do if you have a stateful system maintaining rolling averages, right? Rolling windows. And that's that's a great point, Daniel, right? So everyone talks about microbatching because they're eliding the difference between stream processing and stream analytics. And don't get bamboozled. They're stream processing and doing it faster will solve a few things. Yes, you get your results faster. Like it's a difference between precision and accuracy, right? You basically get your decision faster. So yes, I got data every minute, but how good is that data? Well, that depends on if you're doing stream analytics or you're not.
But that leads to the next question, because you're talking about simplicity. So one of your things that you advocate is breaking the silos. So for companies that didn't have data in one place, they need to get data in one place.
Right.
And doing it batched, like is easier for yesterday, for a couple hours, than streaming. What would be like the same way like we okay to move existing star schema into the BigQuery as is? Like when we're starting that new project, it looks easy.
Right.
It is not to go into streaming data yet. If we don't go there, like are we ever going to catch up with Apache Beam and Dataflow?
Okay, yeah. So that's a good point. If you want, so really, like the thing to remember is that you do not need to always have a stream analytics pipeline, because a data warehouse like BigQuery is streaming by default. As long as you land your data in real time, you can use the tumble keyword in SQL to get stream analytics. All you need to do is to land your data in real time. So land your data in real time, use the tumble keyword, and you are now 90% of the way there to stream analytics. Okay. So how do you land your data in real time? Right? Use a connector. Like if you go to like the BigQuery transfer service, it lands the data in real time. Use a Dataflow template, it lands the data in real time. Use a Fivetran connector, it lands the data in real time. All you need is to land your data in real time into a data warehouse that is streaming by default. Now, okay, only BigQuery is streaming by default, so this only works for BigQuery. But you get the point, right? So if you land your data in real time, and as long as your data warehouse is streaming by default, right, your tumble keyword will give you up to the minute data, and you're done. Yes, Daniel, you are muted.
Can you hear me? I did not know about Fivetran. I thought they are up to 5-minute batches.
Oh, okay. No, again, they're doing mini batching, but only for the landing of data, and you're fine with that. Yeah. So land the data, and then you can still do stream analytics.
I see. That's
right?
Cool. Thank you. Thank you. Anybody else?
Well, I'm not familiar with the GCP query and the BigQuery one that Daniel was just talking about there, but when you're saying you have to use the tumble keyword in order to get that, is it not possible to use the tumble keyword with reference to a data field that represents the time that it landed? Just
absolutely, but you just have to land the data in real time. Just as that's all it is. As long as you land the data in real time, it's not just the tumble keyword. Any aggregation that you do reflects the latest data. And tumble in particular is a moving average. Right? Tumble is how in SQL you do a moving average.
But can you do a moving average on historic data based on a field which tells you when it originally landed because it didn't land in real time now?
Absolutely.
Yeah, that's
you can do that. Yeah.
Okay.
Yeah, and that you can do in pretty much any system.
That's what I expected. I was just a little confused because you said it has to be landing right now in real time. And I was like, well, why can't you just do historical analysis of the same way? But you can. Okay.
Yeah, but my assumption is that you want to make real-time decisions.
For the benefit of where you're going as a business, for sure. Yeah.
Yes. So yes, absolutely. If you do a window function, that's exactly what you're doing, right? A window function is exactly how you basically do and then you do a lag in your window function, and the lag can be a number of rows and the amount of time. And exactly, you basically get your moving average. That's exactly what you want. The problem is it's only historical. And for machine learning, the important thing to realize, you train on historical data, but you predict on real-time data. And you want that predictions to be in real time. And that's where the challenge comes in. You have to land your data in real time for you to be able to predict in real time. And you want to predict in real time to get the value of real time analytics.
Yeah, that makes sense. There's probably a few other cases, like if you're using it for forensic analysis of historic, then, but I understand what you're saying. 95% of the time you're worried about predicting. Yeah, absolutely.
Who's next? I'm lucky, like I can talk to Lak, but like this is for everybody, for the community. So regardless,
it's a very quiet group.
You're a celebrity. People are intimidated.
Okay, so I guess if there are no questions, we finished 8 minutes early, Daniel?
Yes, but we have a draw to do as well. So let me put the survey as well inside. And there are so many things as I was. Okay, I will come with more questions too. So let me paste the survey.
Actually, while you do survey, Lak, I wouldn't mind asking a question because I seen you post on Twitter, BigQuery plus Tableau makes things amazing. We at our company use it, Tableau with BigQuery, but we find that maybe our data set's too big because when we create Tableau reports, it goes back to BigQuery multiple times and that increases costs by quite a bit.
Right.
Do you actually have a thought about it, or
how to best improve it? Figure out if you have that new feature enabled, which it may not be. Okay, so because it's relatively new. And secondly, see if you have BI engine enabled. Right, BI engine will also, even though it goes back to BigQuery, BI engine will do caching, and it will give you a slightly better performance. And I believe, like, if you have, I mean, I don't know what but if you have a BigQuery commit, then you get BI engine for free. You get a certain amount of BI engine for free. But if you're using BigQuery on demand or just trying out BigQuery, you won't get BI engine for free. So at that point, like you might try turning on BI engine.
Oh, okay. Because like we actually have views on top of the tables for security purposes. So I guess there's not a lot of caching that that benefits from Google BigQuery because of the views.
With BI engine, what it will do is it will actually start to cache some of those things, and it will look at when the table has been modified or not, and so on.
Oh, okay. And that other feature you're talking about is Tableau Server?
Yeah, it's a Tableau Server feature, right? So make sure on Tableau Server that you have the in-memory extract turned off. So that so that Tableau is not basically creating that extracts of the data. So those are the two things that I would do.
Okay, thanks.
Sure. And again, these are the kinds of questions. Also, feel free to reach out to your GCP reps, and they know your system. They can actually look at the logs of your queries, etc., to give you suggestions.
Okay, perfect. Yeah, I talked to one of them a couple weeks ago. So
okay, perfect.
Thanks.
So about the visualization tools, like we had a guest recently. He's an Amazon user, Joe Amison, but his analytics is done in BigQuery. And he said he doesn't like to use a Tableau because of the server. You have to run your own server or something. And the Looker is fully
Tableau just changed, where like something like Looker used to always just push all queries to BigQuery and take advantage of that. Looker is just a semantic layer. Tableau, in my understanding, wasn't, and it was pretty expensive in terms of how much it called BigQuery. And there's like the news features have improved Tableau performance against BigQuery. So that's, again, if you looked at Tableau before, it's worth taking a look again, right? In terms of how it uses BigQuery, it's supposed to be better.
Okay, that's cool. And then, so for people who are new to Google, maybe you can emphasize serverless nature and beauty of BigQuery itself, and separation of compute and petabyte storage. like you can do it as a refresher while I'm collecting the names.
Absolutely. While you're pulling up the
survey.
Sure. So one of the neat things I think is that BigQuery separates compute and storage, right? And that's the reason why you get this thing that it's possible. If you're building ML tooling, the ML machines, no matter where they are, can access the data in BigQuery. So you can basically access any data set. It's not like you're not restricted to a cluster. So you never spin up clusters in BigQuery. It's fully serverless. And the way that a Google data center works is that any machine on the data center can access any storage device in that data center as if it were a local device, right? So you basically have all of the machines in that data center accessing all of the storage in that data center as if it were they were reading from local devices. That's what gives us separation of compute and storage, because as long as you put your job on one of those computational machines, they can read any data. So what is true of BigQuery, by the way, is also true of Hadoop. So you can run your Hadoop system, your Spark on one of those compute workloads, and you can put your files in Parquet files on Google Cloud Storage, and it's reading them across the network as if it were a local drive. So even with Spark, you get separation of compute and storage on GCP. So that's a sort of unique capability in that we really do not recommend ever having local disks for Hadoop, because like it doesn't really buy you anything. And instead, when you do Hadoop clusters, you can just do ephemeral jobs of hundreds of machines and get like fast speed up. So that separation of compute and storage really runs through our entire data analytics platform. It's true of BigQuery, as Daniel said, but it's also true of Hadoop. It's true of pretty much all of our DA products.
But the only competing cloud data warehouse that does that is Snowflake. Nobody else does it.
Yeah, other than Snowflake and BigQuery, I don't think anybody else does that separation of compute and storage. And even with the Snowflake, you're basically always specifying the size of your data warehouse for every query, which you don't do on BigQuery, right? It's just all the slots are virtual. They just come out, they come and they go away. So what most companies do is they set up what are called hierarchical reservations. So I will buy 5,000 slots. That's like the size of your data warehouse. And then I would say my team gets 500. And then if I'm not using those 500, my 500 slots transparently flow to the rest of the organization so they can use them if I'm not using them without any coding on their part, right? So that the resources are very, very, very fungible. And that's one huge benefit. So the larger the organization you are, the better off you are, because you kind of have this pooled resources that everybody basically, you get your 500 reserved slots because my department paid for 500, but I still get the advantage of the 4,500 that other people paid for because it's a hierarchical reservation.
Cool. And in one of your talks, you were talking how people, when they're choosing cloud vendors, those check marks like feature by feature, but they have to look under the hood. I think that's important for this group here because we are kind of cross-cloud.
Right. That's true. Again, I mean, I hate to do this really. Here's like this is how we're different as our sales pitch because I'm just not.
It's not a sales pitch. It's important because we're all guilty. We had recently Azure talk, and we were kind of check mark. Oh, this is how we do it in Google. How we do it in.
So again, okay, I won't name names, but people talk about even something as simple as VM migration, right? So what's VM migration on Google Cloud? It is that if I have a VM that's running, security updates will get applied to that VM, and I will never, my processes will never stop running. So you have VMs that have been up for 3 years with multiple versions of security updates and new stuff and all that, and the VM still keeps going because every time we migrate the VM, right? So we basically take all of the work that's running on the VM, we move it onto a new machine, we reboot this machine, we move this back, and it just keeps going, right? If you actually watch like traffic, there's like a slight hiccup when something is being moved and moved back. So that's what we call VM migration. We said, hey, we have VM migration. Everybody's like, okay, we also have VM migration. So there's a checkbox. But when you actually go look at what's the VM migration really doing, they're actually shutting down the VM. The 30 minutes where the VM doesn't do anything. And that's still called VM migration because, yes, the VM is getting migrated. It's not the same thing, though, right? So you have to be, to your point, careful that just because people use the same words, do they mean the same things, right? All these words that we talk about, DataCloud, serverless, separation of compute and storage, right? The details are always different, right? So, it's unfortunate, but that's how it is.
That is cool. So before I do draw, anybody else didn't do the form, it's still in the chat. I can add your names after. Did anybody in the call forget to put the name? Let's start sharing.
Stopped.
Share. And then, so it's only like 6-7 people put their names. Anybody else here that, hey, Danny's here, Danny. Hi.
Yeah,
okay.
I didn't put my name either.
Okay.
Oh, my name got entered. Nice.
I did. You know, Rayleigh, I hope you don't mind reading my link.
No, not problem, actually. Not a problem at all.
Anybody else whose name is not here that I missed?
I'll just put mine. Yeah.
Who is? Okay.
Yeah, I just typed it in the chat. Sorry.
Anybody else? No, so we can do that. Good luck. Anybody else want in? Zoran, are you in? You're not. Who did I forget? Rory, are you with us or just recording? So Rory may not be here. Hey, Harold is here. But Harold, you've read a lot of books so far. You still have to give me reports what you read. So.
That's right. It's time for somebody else to win.
Okay. You have to read what I gave you so far. So, okay, fair. Let's spin. Michael?
Michael.
Okay, let's go.
Yes, thank you.
Hey, so put your email here and the email you use for manning products when you log in inside. And then before next meetup, you will choose anything from manning.com you want. And the folks that work there will put it in your dashboard as if you bought the product. But I need you need your email that you will use to register. Put it into
the email that you use on the platform.
Okay, so I should put my current email into this group chat?
Give it to me. Yeah, put it if you don't mind.
Okay.
Like it's also perfect. Yeah. Perfect. So do we have anything else? Like this is amazing. I feel, yeah. So before other people ask questions, like I see now the gaps in the meetup. I need to have Vertex AI talk, and we need a DataFlow or Apache Beam talk. These are the two areas.
Totally. Yeah.
Anything
One talk
else?
on real-time analytics, and one talk on Vertex AI. And if you need help identifying somebody to speak on those, just reach out to me.
Oh, lovely. Thank you.
Yeah, I can connect you with someone.
Thank you. That's so nice. Any other questions, folks? We still have time. Like normally, like this is not fixed in stone, but like any questions, or we are going to our
In
family?
fact, you have a DataFlow expert in Toronto. We should ask him.
Oh, what is his name?
Yeah, he was working a lot with TELUS in Toronto. So you can have a local expert, which is always better than having somebody from somewhere else.
If we go or in real meetups, he can be here in person. We can have hybrid events.
Exactly.
Well, when are we going to do that, guys, ladies?
I'm sorry?
I'm asking the group, how do you feel about real meetups? Like, I'm still afraid.
I would love it, to be honest.
Jonathan, would you show up?
Oh, it'd be great to get it going again. I'm not sure what the policies and recommendations in that are, but maybe we can do it with some sort of specific adapted guidelines or procedures.
I mean, I play bridge And so 3 weeks ago, we started to play, our club started to do it in person again. And basically, the rule was that you had to come in with a vaccine card and show it. And no vaccination, no play, right? So that was basically the rule. And it's worked great, right? Now we have a couple of players who wear masks because they have kids under 12 at home who are not vaccinated, so they don't want to take it back to them. But other than that, it's been really nice to see friends and in person again. So strongly recommend it.
Yeah, it'd be really good. We might just need a venue with a little more space to keep distance, and maybe we skip the pizza and things like that. But then we should brainstorm it, Daniel, because I'm sure that it's almost time now to, unless there are a few bad trends in some of the numbers and stats we see, but hopefully those discontinue pretty soon.
Mm-hmm. That's cool. But we now have to be hybrid. We cannot go back to old ways. Like it has to be
true. It has to be open to all. That's right. There'll be,
Yeah.
I guess, and I've been in other meetups where they're doing that, where they have an in-person group. Well, this is pre-pandemic, but there'd always be an in-person group and a remote group together. So I'm sure we can come up with something.
Okay, this is easier. I don't have to buy pizza and drinks and drive to downtown. But this is good. Thank you, everyone. So, any last questions? Anything else? No. Thank you for the great books. Like you have a new one. Maybe you can promote it.
Absolutely. I just dropped a link to my book site on Amazon, and like we just published this book on ML for computer vision. So,
perfect. Perfect. Thank you so much. And then if you can send me the updated PDF, I will share it with the group. And give me a week until I edit the recording. I will cut out the first part and I'll leave it up to here.
Awesome.
Thank you so much, Lak. Stay
Cool.
safe.
Thank you very much.
Thank you very much, Lak. That was excellent. Yep.
Yeah,
thanks.
Thank you.
That was excellent talk. Thank you.